Right then, welcome back to my little rant about these things and about AC. Now I've been passing the hint so far that multimeters don't measure AC that well, and we're going to prove that to you right now. Okay, now in some instances they do measure AC very well, okay. In other instances they don't measure it absolutely at all. That's because they've got a very short range for short frequency range for measuring AC. Okay, too low, they don't measure anything. Too high, they don't measure anything. They just work in a very particular range. And the value what they measure AC is not peak to peak. It's not peak. It's not amplitude or anything like that. Not trough. It's actually measured in RMS. Okay, true RMS, the AC equivalent of a DC value. Okay, so if we take the mains UK mains voltage, 230 volts RMS that comes out of your socket. Okay, the actual peak to peak value is closer to what, 660 volts peak to peak. Okay, it's well over double 230 volts what actually comes out your plug socket. But because an AC value oscillates, okay, got our DC. Okay, DC value is a nice consistent straight line. Okay, if we got our AC value, it oscillates positive and negative. So it goes negative, it goes positive, and in between it's an intermediate state. Okay, it's neither its maximum, neither its minimum. So the amount of power, talking about this, we're talking about power rather than volts. Okay, this is a consistent power, and this isn't. The power's fluctuating. So this is actually more power in this one than there is in an AC, which is why the RMS values are a lot lower. Okay, so you have to think it's a bit like the average of this compared to your DC. It's the amount of power that's dumped into your circuit uses. Okay, so if we take a I don't know, a 1 ohm resistor, or well, actually no. Let's do something else. Got here my coffee. Okay, now I used some boiling water to make this with. Okay, and I boiled the water consistently until it was boiling. Okay, it had a consistent value. Okay, so it took this amount of time to boil because I was dumping a consistent power into the liquid. Well, if that was an AC, okay, I'm heating up my water. Okay, it's getting up to temperature, but then it's dropping. Okay, and I'm taking away that heat. Okay, so it's just the heat that's left in the liquid. Okay, and then I'm adding in some more heat. Okay, so it slowly comes up to temperature a little bit more closer to boiling, then it drops off again, and so on. So you need a higher amount of time, if you like, in order to boil that liquid, in order to dump the equivalent amount of power into it. Okay, so there you go. This is a little analogy, if you like. So you've got sine waves on and off. Okay, it goes positive, goes off, goes negative, goes back up again gradually, and so on. There you have it. Okay, and multimeters measure in RMS, but that's not a problem. It's quite nice. Okay, it makes working out calculations a hell of a lot easier. Okay, when you're working with AC values. But when it comes to measuring it, okay, these little babies only work in a very small range, and I will show that to you down here. But before I do that, when you're picking up these, okay, you want to buy one, and I'll say this to you, okay, your manufacturer will hide its range. Okay, they don't want you to know how crap it is at measuring an AC value. They give you that option, but they won't actually tell you the range at which it measures it at on the back of the packet. So if you go into a shop and you're looking at the back of your multimeter value, you'll normally see something like this. They give you all the values up here, okay, and it tells you it can measure DC and AC voltages up to 600 volts. Yeah, okay. It's resistance measurements of 40 mega ohms, continuity, capacitance measurements. It does low impedance measurements on a different model. It's the 115, but it actually specifies that for the 114, 117. So it's you have to be careful which ones you're reading. And on the back here it says frequency to 50 kilohertz. Now, if you didn't pay too much attention to the front of this multimeter, okay, you'd think, oh right, okay, you can measure AC values up to 50 kilohertz. That's pretty good for a multimeter, and it's a fluke multimeter. So I thought, well, yeah, why not? Unfortunately, it doesn't, and the reason it doesn't, because this little frequency value here is the actual frequency range when you measure a frequency. Okay. Not measuring frequency in terms of voltage or current, but measuring frequency in terms of hertz. Okay, because this can actually measure frequency. Okay, the actual measurement for frequency measurement for this multimeter and many other ones. Okay, they're not actually written on the packet; they're buried inside the manual. Okay, so and that's something that you can't get your hands on when it's on the shelf. Okay. Everyone who runs a store must know you absolutely hate us engineers when we go rummaging through boxes and things like that to find out exactly what we get. But that's why, because sometimes it's hidden. So be careful with what you buy. And for these ones, it's only a few kilohertz, 2 kilohertz at the most, before it starts dropping off. These ones exactly the same. And we'll do that now. Right then, here we are. Got our signal generator here. Okay, it's currently set to, I just switched this on, it's currently set to 2 volts peak to peak, and giving out a sine wave of 380.2 hertz. Okay, and let's see what happens when we try and read the output from this. We've got the output down here, main output, which says it, written main output, so connect our BNC cable to this. I'm not using the multimeter probes because it can be a little bit of a pain trying to probe inside a BNC socket, so I've got a BNC cable to some 4mm plugs. Okay, so if we're measuring an AC voltage, let's switch it to the AC range. It's at 2 volts peak to peak, so we'll switch it to 2. Okay, this will be 2 volts RMS maximum that is reading. So RMS of 2 volts, half the amplitude, half it to get the amplitude, that's 1 volt. Okay, and then we take root 2 to get our RMS value, so we're looking at around 0.7. Okay, 0.7 volts we should be expecting. It's our DC equivalent if we're measuring RMS. So plug it into the common as usual, red into red for volts, into measuring volts, and hey presto, there we go. About 0.7 volts, 0.69899. Okay, and there you have it. We're measuring our AC voltage. Now, like I said, if we change the frequency, we drop this down to 38 hertz. Still perfectly fine. Let's drop it down again to 3.8 hertz, and as you can see, our multimeter's starting to fluctuate. Okay, haven't got a clue what the hell it's reading. Okay, so there we go, we've got a problem. Where it actually starts measuring, well, let's increase this. Okay, it's up to 4 hertz, still fluctuating about 5, 10 hertz roughly. Yeah, close. Roughly around 10 hertz. And we slowly reduce this down. There we go, it's starting to flicker about again. So roughly around 10 hertz is where you can start taking your AC measurements using the Beckman. Okay, and let's take a look at the other end. That's low frequencies, high frequencies, 100 hertz, fine. Kilohertz, still fine. 10 kilohertz, new. Okay, it's almost drops by a quarter. Okay, 0.48 millivolts volts. Okay, 484 millivolts it's reading when it should be reading about 7, so obviously it's pretty bad. So let's go back a range, back to 1 kilohertz, because that was okay. Okay, and you can already see it's dropped down by points, because it was 0.699. It's already dropped, already started to give an error, and as we raise our frequency, you can see our multimeter slowly tailing off. Okay, down we go at 2 kilohertz, still not too bad, but it's dropping. Now it starts dropping rapidly. Okay, around 4 kilohertz. 5, we're down 100 millivolts, and up we go, you know, all the way up. So you could say, I don't know, 2 kilohertz is about a maximum, so from 10 hertz to 2 kilohertz your multimeter's fine. Above that it's, or below that, it's pence. And that's why I don't particularly like using them, because you haven't really got that wide range. So if you're testing a filter or anything like that, you're looking at you're probing the circuit with, I don't know, data lines and things like that in the circuit, or you're trying to build a clock or anything like that, you can't use the multimeter for that. Okay, it's completely useless for measuring those sort of values. Other things that I want to point out is that if you're actually measuring square waves, okay, the RMS of a square wave, you can work this one out yourself if you want, is in actual fact the amplitude of the wave. Okay, it's half. Why is it half? Well, I'll give you a hint. Okay, it's on for as long as it's off. There you go. Okay, it's actually just the peak voltage. It's half the peak to peak. Okay, if it's 2 volts, it's actually 1 volt, and let's take a look at that. Okay, let's drop this back down to hertz, 95 hertz. There you go. 2 volts peak to peak is actually almost 1 volt RMS as a square wave. There you have it. Well, that's looking at AC multimeters, and to get a clearer idea of the frequency range, okay, of what it can do and what there actually is in the world, let's have a look on the whiteboard. Well, we'll do a nice graph, and we'll do the frequency response. So this is going to be F, okay, and this is going to be, say, V voltage. Okay, right then. As we said on the multimeter, it goes from up to a couple of K from hertz to about 2 kilohertz. Okay, but in the world we live in, especially in the modern world, frequencies, absolute speed of circuitry is absolutely going mad. Okay, everyone wants faster and faster computers. Everyone wants better mobile phones. Everyone wants to do more and more. Okay. And with that you need processors and data to work quicker and quicker and quicker. Okay. Now, bearing that in mind, okay, and bearing in mind the signal generator that we've got, okay, the actual signal generator I was using can go up to 5 megahertz. Okay, and that's an average everyday signal generator. The loads, I've got signal generators in the lab that go up to gigahertz. Okay, and a couple of them that go up to tens of gigahertz and so on and so forth. So gigahertz compared to kilohertz is absolutely nothing, especially nowadays. I mean, take your desktop computer, what's in gigahertz, you know. You try and probe your bus line with a multimeter nowadays, and it's like, don't even bother when it was, you know, 10-15 years ago. Multimeter really fell behind for measuring the AC signals, especially with the advent of digital logic now. You know, designed to measure sinusoidals, well, they're going out the window really, unless you're doing these very basic measurements, or if you're measuring mains and you're doing power supply work or lighting in the home, things like that, then they're perfectly fine. But for electronic engineering, measuring the AC on them isn't really all that. So back to the graph, okay. Because we're working in frequency, okay, we're going to do it in logs, okay, because the frequency range is huge. So, you know, log of, we've got 10 hertz, so log of 10 hertz is equal to 1 kilohertz, you know, 100 hertz is 2, kilohertz is 3, and so on. So we'll do 1, 2, 3, 4, 5, 6 megs, okay, and so on, you know, 7, tens of megs, 8s, hundreds of megs, and so on. And bearing that in mind, with the multimeter, okay, it actually works from roughly somewhere around, say, what was it, 10 hertz? So it's working perfectly fine around 10 hertz. Let's put a dot there. Up to kilohertz, which was down here, so 3 here. So it was only really working, it didn't work at all well below 10 at all. It was really great, so it's down here somewhere. Yeah, it really tailed off, and so up here around 10 kilohertz, 4, okay, it's getting half, so it really did tail off. You know, 100 kilohertz, you're almost getting nothing. So if you imagine that, this is only a meg, well, gigahertz is down here somewhere. So if this is on a gigahertz range, this was, I don't know, hertz here, we've got gigahertz up here, okay, and megahertz is somewhere here. A multimeter's response will be somewhere, somewhere around this region here, okay, compared to all of this. Okay, so begs the question of why it's actually there and why it's still used a great deal, and why it's such a still such a strong selling point on multimeters. Why do manufacturers put it on there when the world is taking off ahead of them? What I would like to see is this range, okay, your range on your multimeter, please expand it, you know. Let us read signals above kilohertz. Okay, if not, you know, you're going to stick to it, then why not get rid of it? And I mean, for the price of £150 multimeter, you can get yourself a cheap and cheerful oscilloscope, you know, that can measure kilohertz perfectly fine. You know, what's the point? You can actually see the waveform as well. This is just numbers, you know. If you got if you're trying to test a circuit, okay, it's meant to be a sine wave, but it isn't, then the multimeter isn't really going to help you at all measuring AC. Okay, it's only really useful if you know what you're getting, and if you know what you're getting, then what's the point in using it? Check it out the window. Anyway, that's AC on multimeters. Been concentrating on volts. Okay, exactly the same problem when you're doing current as well, except you use them in series, just like when you're measuring DC current, use them in series for measuring AC currents, okay, and it's still got exactly the same frequency range, okay, and I'm out of here. Next up, we'll look at measuring component values, okay, continuity, resistance, capacitance, diodes, transistors. We'll do all that in one hit, okay, because once you know how to do one resistors, the same thing is applied to all the other components. Okay, you'll measure them in much the same way. That's that.